In this video, we'll be looking at our first lesson in Chapter 1, 1.6, Relations. So our central question today will be, how do I represent relations? How do I represent relations and find their domain and range? So we'll have some old vocabulary that we talk about and possibly some new vocabulary that we'll talk about. First thing we want to talk about is an ordered pair. This should be fairly old vocabulary to you. An ordered pair is just the x comma y. Next we'll talk about relation. A relation is a set of ordered pairs. So if we have multiple xy's and we kind of list them, that would be the set of ordered pairs. So that is a relation. Domain is all possible x values. And the range, since we're talking about all possible x values, what do we think the range will be? All possible y values. So this stuff is pretty straightforward. There's a lot of listing, a lot of plotting. There's not much addition, subtraction, multiplication, or division. It's really getting comfortable with definitions and vocabulary. So let's look at number 1. Express the relation as a table, a graph, and a mapping diagram. Then determine the domain and range. So a table is this one right here. This is our table. And what we'll do is here's our set, here's our relation, it's our set of ordered pairs, and we'll list our x values in our x column, and then we'll list our y values in our y column. So we'll put our x values, and we're just going to list all the x values. So I have 2, -2, 5, -1. And when you're setting up a table, you want to make sure that your x values correspond with the y values, like in the ordered pair. So if I have 2 first, I will put 5 first. So let's do our y values. And now I'm going to use the ordered pairs, so 2, 5, and then -2, 3, 5, -2, and then -1, -2. Graphing, I think we all know how to graph, so we're just going to plot these ordered pairs. We're not going to connect them because this isn't a line. It's not representing all of the possible solutions. We're just representing these 4 points. So let's plot them. So here's my x, here's my y, and we'll go over 2, and then up 1, or up 5. 2, 1, 2, 3, 4, 5. So there's our first point, the 2, 5. We're just going to plot all 4 of these. -2, 3. X coming first, then our y. 5, -2. 1, 2, 3, 4, 5, 1, 2, -2. And then our last point, -1, -2. Let me plot it. And so this is a graph. Next we'll do a mapping. And a mapping is when we list our x values and we list our y values, and we want to list them in order, and then we'll draw arrows to connect them to the ordered pairs. So let's list our x values. I'm going to list them in numerical order. So my lowest one's -2, then I have a -1, and then I have a 2, and then 5. Then I'll list my y values. My lowest value of y is -2, and it's listed twice, but we only need to write it once. We'll see why in a second. And then I'll have my 3, and then my 5. And now to map, I'm just going to draw an arrow that connects my x value to the corresponding y value. So on my first point, if I have a 2, I'll draw an arrow to the 5. Kind of like a map where the arrow points in the direction where if I start at 2, I end up at 5. If I start at -2, I end up at 3. If I start at 5, I end up at -2. And if I start at -1, I end up at -2. So this is exactly why the 5 and -1, we only need one -2, because I'm just drawing an arrow to represent where, if I'm starting somewhere, where it ends up. So we can have two arrows end up at the same value. So that's how we can do a table, graph, and mapping. Go ahead and try number 2 on your own, and then it's given as a table, and then I would like you to write out the ordered pairs, and then we will do graph them and do a mapping. So the first thing you'll do is you'll take this table that's given and you'll write out ordered pairs like this. Let me give you an example of the first one. I would have 3, -2. So finish up our our set of ordered pairs, and then we'll graph them, and then we'll create a mapping. So pause here and try that on your own. Okay, so hopefully you tried that on your own. I'm going to go ahead and move through this pretty quickly. Just writing out my ordered pairs. 5, -1, 4, 0, and 3, 1. So there's my set of ordered pairs. Now we'll graph this set. We've got 3, -2, 5, -1, 4, 0, and 3, 1. Like so. There's our graphing. Now we'll do our mapping, where we have our x, y. So we list all our x's and all our y's in numerical order. So I have 3, 4, 5. So we'll do in that order. 3, 4, 5. Then I'll list my y's in numerical order. -2, -1, 0, 1. -2, -1, 0, 1. And then we'll just do a mapping connecting the x to the y. So 3 connects to -2, 5 connects to -1, 4 connects to 0, and then the second 3 connects to the 1, like so. Okay, now we want to talk about our domain and range. So the domain is just a list of all the x values. So if I wanted to talk about domain, I would just say the domain is 3, 4, 5. And it looks just like that. All I did is I have D for domain, colon, our little squiggly bracket, and then I just list my x values. Range will be something quite similar, but instead of listing all the x values, we'll list all the y values. So I'll put my R, colon, squiggly bracket, and then I just list all my y values. -2, comma, -1, comma, 0, comma, 1. And there's our domain and range. This is the notation we'll be looking for. You don't have to write the word domain if you just write this. This is the important piece right here is this. This is what we'll be looking for in writing. Okay, let's flip to the back. Now our independent variable and dependent variables is simply like one's an input and the other is an output. So an independent variable is the variable that does not rely on the other variable, also known as the input. A little side note, typically the x value. So things that are independent variables are things such as time. Time's forever moving. We usually input time, and things are time does not rely on anything else, but a lot of other things rely on time. So it's a very usual independent variable. A dependent variable is the variable that does rely on the other variable. And this is our output. And that will typically be the y value. So our x's are typically our inputs. We do our math, and then a number pops out, and that's our output, our y value. So using these definitions, try number 4 and 5 on your own. See if you can identify what is an independent variable and what is a dependent variable. Pause right here and read 4 and 5 and see if you can identify that. Okay, so hopefully you tried these. The dance committee is selling tickets to the fall ball. The more tickets they sell, the greater the amount of money they can spend for decorations. Identify the independent and dependent variables for the relation. Well, the thinking is what is independent and what is dependent. So who's relying on who? So when we look at this, it seems like the money for decorations is relying on the amount of tickets being sold. So we need to sell tickets to have money for the decorations. So we'll say that our independent is the number of tickets sold, and our dependent is the amount of money for decorations. So we need to know how many tickets we sold. We need to sell tickets to have money for our decorations. So number 5, generally the average price of going to the movies has steadily increased over time. Identify the independent and dependent variables for the relationship. Well, the thing that we are dependent on is time. time is the thing that is constantly changing, and as time moves along, our prices change based on how much time has passed. So we will say that the independent is time, and the dependent is the cost of the movie. The more time that passes, the higher the cost of the movie. Now 6 and 7 are pretty straightforward, mainly because we're just going to use that idea that independent is typically our x value and dependent is typically our y value. So we're just going to use our words that go with that. So for number 6, I would say that the independent is time, and my dependent is speed. So I just used my x, the label for my x-axis, time. Right here, there's my dependent, and then my label for my y value was speed. So that's how it's pretty simple to look at a graph and identify what our independent and dependent variables are. So go ahead, try number 7 real quick. Should be fairly straightforward. And yes, our dependent will be time, and our independent will be our account balance. So our independent is time. Sorry, I misspoke. Our independent is time, and our dependent is our account balance. Like that. So that's how we can use a graph to identify our independent and dependent variables. So thank you for watching this video, and I hope you have a great rest of your day.